Greetings and welcome, friends, boys and girls, math fans of all ages. Today, we are going back, flashback. We're time traveling to the world, the kingdom of algebra wondom. And we're going to be applying our logic, our justification, right? Our means of communicating, our reasoning abilities. We're going to be reasoning with algebra using some of our old school properties. And this is going to set us up for success with geometry, really, is what we're going to do. So hopefully we're going to apply this in an area that you are familiar with so that you can track with us into unknown territory. So here we go. Core concept, algebraic properties of equality. Assume A, B, and C are the realest of numbers. Yes, someday you will be learning about unreal, non-real, imaginary numbers. But yeah, here, check this out. Addition property of equality. If A equals B, then I can add the same thing to both sides, and it maintains equality. Subtraction, subtract the same thing from both sides, and it maintains its equality, right? It's like add the same thing to both sides of a balanced scale, and it will still be balanced when all is said and done. Same thing is true for multiplicado. Maintains the equality. They said, hey, don't let the C equal 0. All right, I guess. Although it's whatever. Let's see. If A equals B, I can divide both sides by the same value, right? And it will still be equal. However, C cannot equal 0. In this case, even more so, because dividing by 0 results in undefinition, undefined. That's when that's how black holes exist, almost. Not quite, but like the universe just falls apart mathematically when you divide by 0. Don't do it. If A equals B, then A can be substituted for B or B for A in any equation or expression. Good times. Good times. So let's do some examples here. We are going to be aware of these properties. And notice the key here is not just solving, but justifying. All right, justifying. And I'm going to actually set up kind of a table over here, all right, where I'm going to have my statements and my reasons. Because of reasons, that's why. It's good enough. So here we go. The original statement, 3x plus 2 equals 23 minus 4x. The reason that's true is someone told me so. Given. All right, that's the gimme right there. Seriously, for the rest of this course, when we're doing proofs, given. Like, you got to at least get the given, guys. You got to at least get the given. So let's see. If I want to solve this for x, I'm going to show more steps than the book will. I need to select the right tone hue there. Add 4x to both sides, right? My variables are on opposite sides of the equation. I got to bring them together. So I'm going to have 7x, here's my next statement, plus 2 equals 23. Why is that true? Which property did I apply? Addition, add, prop. All right, I know the other math teacher is going to be so mad at me for this. Add, prop, equal. Man, me and my math slang. But seriously, mathematicians, we are efficiently lazy people. I want to communicate things with symbols. Don't make me use words. Come on now. So here we go. To solve now, two things are happening to x. It's being multiplied by 7 and added by 2. If I'm going to diffuse this bomb, I've got to do it in the reverse order in which it was assembled. So I'm going to SADMEP instead of PEMDAS. I'm going to deal with addition before I deal with the multiplication. So the inverse operation of adding 2 is subtracting 2 from both sides. Oh, man, that might have given some hints as to which property justifies that step. You can guess it. The subt. And yeah, you need the T for subbed because otherwise you might assume substitution. Subtraction property of equality. Good times. And let's see, here we go to solve for x. It's being multiplied by 7. Inverse operation, divide. Man, are you guys happy to be back with algebra? You're so happy, aren't you? Like, isn't there just, there's this joy here. So I found out that x equals 3, and this last step was justified by the div prop of equality, right? Good times. So this idea of being able to make a statement and then justify it with a reason is something that we're going to do throughout geometry. I like these two-column proofs, but we'll also see paragraph proof format. We'll do things like that as well. Flowchart proofs. Yeah, there we go. All right, here's a distributive property, another property to be aware of. If I've got A, B, and C real numbers, if A is being multiplied by the sum of B plus C, I distribute it. Distributing A times B plus A times C. It also applies over subtraction. So multiplication is distributive over addition or subtraction is the idea. So that's another means through which I can use that property to justify the work that I do. So here we go. Let's see. I'm going to do an example. And guys, you know what? It's probably going to use that property. I have a feeling. I mean, it even just tells me it's using the distributive property. Okay? So here we go. So let's see if I can justify each step. Maybe we'll break away from the two columns just a little bit here. So the first thing I would do is distribute. I'll get negative 35 dubs minus 40. Often students make this a plus sign. They don't realize that the minus is hitting the second number, the second term in the parentheses, equals 30. Why is that true? You guys know it. Distributive property. Do I need equality there? I don't think so. No, just straight up distributing. And now I can solve, add 40 to both sides. I've got, let's see, negative 35W equals 70. Why is that true? Addition property of equality. Add prop. Equality. I do need the equal sign there. And I guess I should abbreviate. There we go. Bam. And what do we think? Do I add 35 to both sides here, guys? No. The operation is multiplication. So the inverse operation would be to divide by negative 35. And I'll get W is equal to negative 2 by the looks of things. The reason that's true, div prop of equality. All right, so these are nice little problems that we've got, right? Not too crazy. I'm going to put up 3 other properties that you guys are familiar with. I know you guys are packing up, class is heading out, but the internet and the show will go on, so don't you worry. Let's see, core concept, reflexive, symmetric, and transitive properties of equality. Reflexive property, now these are applying to equality, but we will end up also having similar properties with, you guessed it, congruence. Yeah. Same names, just it'll have congruence instead of equality. So here we go. Reflexive property, basic idea, anything is equal to itself. It can be true with numbers. It can be true with lengths of segments, which are also numbers. It can be true with measures of angles, which are also numbers. Good stuff. All right, anything is equal to itself. Reflexive, think like reflection, right? In a mirror, there's like this equal sign is like a little mirror or something like that. That makes sense. Symmetric property of equality. If A equals B, then B equals A. Oh man, guys, I think I've been telling my Algebra 1 class the wrong name for like the last 2 weeks. That's pretty amazing. That's fine. I haven't really taught Algebra 1 in like 8 years though, so cut me some slack, friends. So yeah, symmetric property. It's symmetric. You swap the location, it's still true. That's the way equality works. Have a good weekend, friends. And the transitive property, we've already referred to this earlier on in this chapter when we were talking about the law of syllogism, right? That if A equals B and if B equals C, then A equals C. You need more time? Yeah, what's up? It's okay. So let's do one last example now that all my friends are gone. And here we go. Example 4. You reflect the beam of a spotlight off a mirror laying flat on a stage as shown. Determine whether the measure of angle dBA, so let's see, dBA, okay, so that's this big angle here. Let's see, let me get a better color to show that right here. So this angle, show that that is equal to the measure of EBC. So that's what we're trying to prove right there. Okay. So so looks like based on what we have given, I could say that the measure of angle, let's say they started with a D, so DBC is equal to the measure of angle EBA. And the reason I know that is because they told me. So given is a sufficient explanation for that. Now notice angle 2 is kind of what I have to include here. So what I'm going to write is this. I'm going to add angle 2 to both of these sides of the equation. So measure of angle DBC plus the measure of angle 2 is going to equal the measure of angle EBA plus the measure of angle 2. Now the reason that is true is addition property of equality. Add prop equal, right? I've just added the same thing to both sides. Now, this next piece, I'm going to actually be able to substitute some of this here, or maybe be able to rename this. So the measure of angle DBC plus the measure of angle 2 is this angle and this angle. I'm going to try to rename that as EBC. And so I'm going to do that. I'm going to say this about, or sorry, EBC. I'm going to say the measure of angle EBC is equal to angle 1 plus angle 2, or maybe I'll use those names since I've already used that. Measure of angle DBC plus the measure of angle 2. Now, why is that true? That's true because of angle addition postulate. Angle addition postulate, right? The idea that the big angle is equal to the sum of the two small angles is what we've got going there. And so through substitution, if this is equal to that, now I can substitute their values at any time. So I'm going to take this and plug it in for this entire side in just a moment. But let me first do angle addition postulate for this next statement. So I'm going to say that the measure of angle DBC is going to equal these two things, right? Angle 3 plus angle 2. So measure of angle EBA plus the measure of angle 2. That's true. And look at this shortcut I give you. Quotes, just ditto marks. I guess technically you should ditto under each word, but that's fine. It's the same reason. And in a moment, I'm going to substitute this in for this expression. And so let's make that substitution. So I'm going to say the measure of angle EBC is equal to the measure of angle DBC. And the reason that's true is substitution. So subs prop. Okay? So substitution property of equality is what I end up getting. And I believe that is roughly what I've set out to prove. But tell you what, let's flip it around and do it proper. Measure of angle DBC. Oh, wait a minute. Did I mess this up? DBA. This was supposed to be an A the whole time, guys. Blast. DBA. And DBA is equal to the measure of angle And did I mess up on this one too? EB. How did I get? Guys, I named these wrong. How did I do that? No, EBC was right. EBC, okay. And the reason that's true is symmetric property of equality. All right, so that's the way that we use our postulates, our definitions, all of our properties, and we use those to justify the arguments that we're making. All right, thanks for watching, Internet friends. Bye-bye.